Hi there, Nick here, M0NTV, and welcome back to my shack and to another homebrew video, but not the one I promised you last time. It's coming, the mixers are coming, do not fear, but I wanted to do something different first of all, for two reasons. Firstly, this radio, unlike any of the other radios that I've built, where usually I just build it all first, loads of separate modules, rat's nest of wires and cables all over the bench, then think about putting it into an enclosure. You'll remember that the first video of this series, I challenged myself to fit it into that quite small, little blue box. So I've always had that in mind, and so what I want to do actually today is just show you very briefly some of the work I've been doing on the front panel, because while I've been building the VFO, I've had in mind where all these things are actually going to sit and fit. And that brings me on to the second thing, which is a bit of an embarrassing admission to have to make because the last two videos have been about this multi-function digital VFO. Well, last weekend it stopped functioning, which is kind of embarrassing. Now, it didn't go up in a puff of magic smoke or anything like that. What happened is that the voltage regulator on the Arduino stopped regulating, and so, as I say, there was no bang, sparks, magic smoke released, but suddenly I realised that actually it was trying to draw way more current than it should ever need. Now, fortunately, I did have some overcurrent protection on the desktop power supply I've got here, but not enough. And it's caught me on the hop really. So it clearly wasn't regulating it. So it's failed. I probably fried it. I don't remember frying it, but yeah, it died. Now that ordinarily wouldn't be a problem. Arduino Nanos are not very expensive. I could have taken it out, put a new one in. But you will remember I took the decision to solder the thing in, didn't I? Instead of using header pins, because I was trying to keep the physical height down. I regret that decision. Bitterly, because I've had to rebuild the entire VFO, which wasn't so bad because obviously I'd already done it once. All the wires and components, I could use virtually all of them on the new design. It also gave me the opportunity to do a couple of things differently, which is good. And every day's a school day, as they say, really. So I could have done without it. It has set me back a little bit, but I think I've got something a bit better at the end of it. So that's what I'm going to show you. First of all, the changes I've made to Mark II of the VFO, and then how that actually fits into my front panel. And you'll see the rig is starting to come together. So I hope you enjoy. Okay, well, here is Mark II, and you'll see it looks fairly similar, except the one thing you'll probably notice is it's much taller, and you can see it needed to be taller because I had to accommodate, well, first of all, the voltage regulators down the bottom left. I'll talk about them in a minute, but also you can see the Nano there up on the header pins, and so everything had to be taller. And you can probably just about see, if I can turn this around, that the TFT screen you'll see is actually on these long header pins. So there's a strip of header pins actually soldered into the strip board, and then there's these other ones which are got the very long pins which it's kind of going into. So what I'm going to do is I'm just going to take the screen off for a moment so you can see what's underneath. So it looks pretty similar, but I wasn't going to make the same mistake of soldering that
Arduino in again. I did choose to solder the SI5351 again because, to be honest, it's only 4 pins, so if I had to take it out, I'd take it out. So it's fairly similar. I've got all the connections coming down the bottom this time because that was easier to do. I think there's probably only about 3 differences to point your attention to. The filter, this is the audio filter for the tuning tone, and it was just easier as I've used a larger piece of strip board, and you can see these lines. There's a line there and there's a line there. That marks the size of the old board, so you can see this one is wider, and it gave me a bit more space. So rather than trying to cram it all in at the top here as the old one was, I've got it down the side, so that was good. Other things I've done, I've recreated the S meter little rectifying circuit down here again. The only thing that's different, and you probably can't see this very well, but there is, you can just about see, there's another diode. That diode there, right up against the header pins, is a 4.7 volt Zener diode. And I had some conversation with Steve Hartley from the GQRP Club, and he sent me a schematic that I think had appeared in Sprat some time ago for using an S meter with a digital VFO. And one of the things it had was a Zener there, just to safeguard the 5 volt pins on your Nano. So below 4.7 volts, it's fine. It'll go relatively unattenuated. But once you get to 4.7 volts, anything over that really is going to start to be shunted to ground. So it will just safeguard your 5 volt pin. So that seemed like a good idea. So I did that. The rest of it is the same. The main difference, of course, is how I'm powering it. Now, the last version 1 just had, I was running it on 9 volts. It was going straight into the Nano. And then the other peripherals, the SI5351, the TFT screen, and the rotary encoder, were all coming from the 5 volt pin on the Nano. But I wanted to do real belt and braces with this. So what I've got here is these back-to-back voltage. This first one, so I'm feeding 12 volts in now. So 12 volts is coming into here, into this voltage regulator. And that is sending, and the V in line, 9 volts. That's a 9 volt voltage regulator. So I'm regulating down from 12 to 9. So I've got 9 volts then, stable volts going into the V in. But what I've done is I disconnected the 5 volt pin from this 5 volt line, basically, that was going in there. So all the Nano's got to worry about is itself, none of the peripherals, right? So what's happening is the 12 volts coming in down to 9 volts. And so that's going into the V-in of the Nano, and the voltage regulator on the Nano then will take that down to 5. But that's all it's worrying about, because this second one is a 5 volt regulator. So when the V-in goes in with the 9 volts, also some of that is going into the 5 volt voltage regulator, and that then is feeding 5 volts to the SI5351, the TFT screen, and to the rotary encoder. So they're all being powered separately, not by the Nano, and hopefully that will help things a bit. So I'm not going to be asking too much of the Nano. I don't think I was asking too much of the Nano, but anyway, better be safe than sorry. So I think that is pretty much it. All of the changes really are more kind of cosmetic, and yes, so that's it. Now, one of the reasons I wanted to kind of show you this, and it works, of course. I mean, most importantly, one of the reasons was that I've been doing some work behind the scenes on the actual chassis that this radio is going to go in, and particularly on the front panel. And what I'd like to do now is actually, now I've got this thing together, is actually to fix it to the front panel, and which I've never done before. Normally that only happens when the whole rig is built and tested, but I'd kind of like to do that as I go along, and hopefully it will help me to just keep in mind the enclosure space. So as I'm building things, I'm not going to build things that I don't really have the room to accommodate. So that's the next thing. I want to show you my designs for the front panel, and then hopefully get this thing built into it. Right, full disclosure. Me and me big mouth, right? Talking about, oh, if I have to move the SI 5351, it's only 4 pins. Well, guess what? I had to move it again, because what I hadn't realised is, you see this hole here, which is for the standoffs to go in. There's going to be a standoff coming in down that it's going to fit onto. There wasn't room where it was, so I've had to shift the whole thing 4 pins down and do some shifting of the wiring as well to this as well. So I mean, you could barely tell really, because most of it's underneath. But annoying, and it shows you, with the best will in the world, sometimes your electrical brain doesn't match up with the physical mechanical brain of how these things are all going to kind of play nicely with each other. So anyway, I've now moved it, tested it, it all still works great. So now I can get on with the business of actually attaching it to the panel. So this is how I started. So I literally just took the front panel off, drew round it on a piece of A4 paper, and then decided where the main things were going to go. And so the round shape on the left is going to be where the speaker is going to be, and so obviously I'm going to need to make holes in there to let the sound out. The rectangular shape in the middle is going to be where the TFT screen is going to go, and I've actually got a little bezel that will fit in there, and then the other controls will go on the right hand side where there's a big blank space at the moment. So that will be the microphone in, that'll be the audio volume, it'll be the tuning obviously, and it'll be the switches for the switching the bands and switching the tuning tone. And here is the front panel. So you will see the pattern of holes that I drilled in to accommodate the speaker, and the holes at the top and the bottom that it's going to actually bolt on with. We'll come back to the TFT screen at the minute. There's the other holes down the bottom here for the various switches, and for the volume control. The big hole here is for the rotary encoder for the tuning, and the small hole there is for the microphone input. Now, drilling holes, it's a bit boring sometimes, and if I have to say I'm not an expert when it comes to coding, or indeed to building radios, when it comes to metal work, that goes doubly. Right, but I do me best. Yeah, and all I can say is I've got better. If you think this was bad, you should see me earlier attempts. Now drilling holes it's not too bad. I mean, it's fairly chunky, this really, but it's all right. The hardest thing, of course, and the thing that a lot of people struggle with, is how do you cut straight rectangular bits of metal out for your screens. That's more challenging. How I do it, and it's not necessarily the best way, it's just the way I do it, is that I would drill, I think on this instance I drilled a lot of little holes all the way along, But what I need to do is to have 4 big holes in each corner, big enough to accommodate my metal nibblers. And these are said nibblers. Other brands are available, and essentially you have to just get the end in there. So you need a big enough hole to get that little tooth bit in. Once it's in, it's easy life, and you pump it, and it's a bit like opening a can of sardines. It all scrolls up. The metal that you cut out, and you can get some pretty reasonably straight edges, and it will cut through some fairly thick sheets of metal. So that's not too bad once you get going. When you've done it, it will probably not be that pretty. In which case, you get going with just some metal files then, and file off the sharp edges and things. Do your best with that, and then I've just wrapped some electrical tape around it here, but that isn't finished yet, because then what happens is I bought, it's still got the protective thing that will come off obviously. This fits over the screen, and actually that will kind of come in here, and that will pop in there, and so that will fit the size of the screen. So this will just look a lot smarter when it's on there. On the other side, you can see I've got these standoffs which are connected there. I could only accommodate 3, but that's fine. That should be more than enough to keep it secure. And that is what my strip board with the VFO is going to connect to. And if I've got the height calculations right, that it should all go in there nice and snugly and nice and securely. And then hopefully the wires that I put on will be the right length then to fit to the various switches. Obviously I've not got a volume control yet, because I've not got an audio amplifier yet, but that's there for when it is. But I can use most of these and actually get the parts on there. So that's what I'm going to do next. And so here it is. So this is my front panel of the new radio, and so I've got a nice kind of chunky knob on this. You can really feel it as it increments round. That's nice. Got little switches here, and that's going to be the volume going in there, that potentiometer. Obviously the speaker's not in yet, and that's going to be the microphone input. Let me just turn this around and show you what it looks like on the other side. So, okay, so we see it all went in fairly neatly in the end. There's the rotary encoder. We've got the 2 switches down the bottom here. And yeah, all the VFO is supported by those 3 little PCB mounting little columns there. And you can see all that goes in. And yeah, it's pretty well behaved, all in all. So let me just fire it up, and you can see what it looks like. So here it is. I've just fired it up, and you can see where, I'm not sure I can do this, so you can see it like that probably. Yeah, tuning nice and smoothly in the 1 kilohertz increments, and all the functionality works. So yeah, changing to 10k, 100k, 1 meg, 1, 10, 100, and back to 1 kilohertz. Yeah, this is the band change. So if I flick that, we're on 10 meters now. Flick it back down, we're back to 15. And that's a tuning tone. So if I press that somewhere behind, I've got the PTT. Now it's around here. Hang on. If I just connect those, you might be able to see. Get the tuning. Yeah, with the tuning tone in there. Flick that off. And now it's just transmit, no tuning. So, yeah, quite pleased with that.
So there it is, and I hope you found something of interest there. Next time, I promise, mixers. And now, those of you that have followed my channel for a while will know I've already got a trilogy of videos on home brewing a double balanced diode ring mixer, so I'm not just going to repeat all that stuff. But what I haven't tackled before is when you use a mixer as a product detector / balance modulator, and that is critical, more critical than the first mixer on receive, second mixer on transmit, and that's what we're going to spend most of our time looking at next time. But that is for next time. Until then, thank you very much for watching, and 73, see you soon. Bye bye.